Um, but the last part of quiz one was the new part. So that's how the quizzes are always written. To get an A on the quiz or to get through that last part, it's always going to be something that you haven't exactly seen before. So you've done an input prompt, but you'd never done an input prompt with a string. So an input prompt with a string requires you to either, in option one here, enter in the prompt as a string. So you have to use single quotes when you put in your name, Shannon. Or you can add an S after the input prompt that you define, and then you don't have to distinguish that it's a string when you enter it in when you run it. So either works the same. And the way that you determine something like that on a quiz is that you go read the input function in the help to see, okay, I'm not doing a number now, I'm doing a string, how do I do that? And that's what I'm looking for you to kind of develop through this course, is to be able to do that. The display, this was done on the quiz and in the lab, actually in both labs, is basically you could use either fprintf or display command, and again, it's important that you just know the syntax for both. Sometimes fprintf is easier and sometimes disp is easier, and just being able to do both is beneficial. So remember that with the disp syntax, you add parentheses around the function disp, and then you add square brackets to put more than one thing in the disp command. You go ahead and put commas between everything you want to display. And then if it's not a string, like a variable that's holding a value, then you need to use num to string. Fprintf is completely different. You put in the string and you put percentage signs where you want to put in a variable. And then if it's a string, you use %s. And then if it's a number, you use %f. Or in lab 2, you can use %e, which is an scientific notation. But there's actually quite a few different. So we just finished up topic 2, and that's what you're going to be taking a quiz on the next Monday, Tuesday labs. So what we did in topic 2 is we learned how to create, access, and manipulate arrays. One big part of this topic is understanding the difference between using the multiplication sign and the dot multiplication sign. And as I've mentioned, almost exclusively we're using element by element multiplication. The exception for that is the last topic in this class where we do linear algebra. And that's the only time we're using matrix multiplication. A big part of arrays is array accessing. So in your lab, you learned how to index an array to access elements of the array that you need. So for example, in the second part of lab 2, you have a huge table of data, but sometimes you only need certain columns, sometimes you only need the last element of the second column, and the lab has you start thinking about how to access those properly. And remember that there's single and double index notation. Single will be just counting elements. I think it actually goes down the column and then back up, so it's like 1, 2, 3, 4, 20. 21, 40. That's not a very good way to access elements because you have to count through the table. It's much easier to use the row column notation, the double notation. We use several new functions in this topic: length, size, ones, zeros, and reshape. Some people use reshape, you don't usually need it. But they're basically different functions that allow you to understand different things about your arrays. But we also use 2 new functions, the find and the max function. So all of these things will definitely be on the quiz. So you will be asked to use the find function, you will be asked to use the max function. And so make sure that you are comfortable with those. My tips for topic 2, these are things that I always notice happen around this time. I made 2 mistakes here in the command window, and both of them gave me the same error, but they are totally different mistakes. So the first mistake is I created an array that has 10 elements, and then I tried to access the 11th element, which there is not one. So the error says index exceeds matrix dimensions, and I feel like that's a very useful error. Like you're like, oh, okay, I got that one, right? However, you get the same error if you do this. So I overwrote the disp function, I used it as a variable, and I overwrote it with the value 15. Then I decided later on in my code that I wanted to use that function, so I just was putting in a display into the function, and I get the exact same error. And that's because disp is now a 1-by-1 array, and I am putting a string into it. The string is converted into a number, and then it's trying to access that number's element in that disp array. So that you have to go many steps to get to what the problem is, but that's often the problem when you overwrite a function name. It's very difficult to see the mistake usually. So always think about that. Did I overwrite? Max always gets overwritten. Like it always happens because you like are calculating a max and you're like, oh, that would be a great variable name, max. But then you overwrite the function, okay? I wish they would like, eventually they're probably gonna not, but they still do in MATLAB. Are there any questions about that? About any of that? Yeah.
Yeah, so you said the A grade on the quizzes is kind of new stuff. Is there a way to prepare for that?
So it's not, I wouldn't say it's new, but it's going to have you go one step beyond. Like with the input, you're still using the input function, so it'll usually ask you to use like a feature of a function or something that you have not done before. So the best way to prepare is to continue to practice to use the help, because you'll need to be able to use the help in order to determine how to use the function differently, where everything else is just doing exactly what you did before but with different numbers. If that makes sense. And it's always a little bit different, but that's just how you should expect. And yeah, any other questions?
So for the last part, we're always using the help.
You'll probably need to use the help, yeah. Yeah, or sometimes sometimes it's just something that was like in the pre-lab or something. Like it wasn't directly in the lab, so you'll have to go back to the pre-lab and look at what you did there. It's not as straightforward. You know, I think getting a B means that you, that I've really thought about like what a B should be, you know, and a B means like you got it, like you did everything and you got it. But to me an A means like you deeply understand it so you can apply it in a slightly different situation. Okay, any other questions? Yeah.
You overwrite something, how do you overwrite it?
Oh, that's a good question. So you, if you overwrite a variable, you need to clear out your variables. So you should always type, the problem is you should always have clear all at the top of your file, but if you overwrote the variable in your file, then you need to remove that line, obviously, or change the variable name. If you're in the command window and you overwrote it, you can either type clear all to clear it, or you can just type clear space that variable. So you can just like type clear space max, and that will just clear that variable, and it'll go back to normal.
Did anything ever bad happen? Do too much when you clear all?
No, you will always get a warning when you type clear all because you're clearing out stuff that MATLAB then goes a little bit slower the next time it runs. But for us in this class, it's just the safest thing when we're doing these quizzes to make sure that you don't have anything different about your system. You can type the word clear and not clear all, and that's what MATLAB recommends. Any other questions? Okay, so today we are going to start plotting. This is universally everyone's very favorite topic. And I used to introduce this topic at topic 8. Last semester was my first semester. I introduced it at topic 3, and that is because all of you are such visual learners. And so now we get to start using plotting in all the topics right away. So I've passed out a handout that has all of the syntax, plotting syntax that I'm going to be showing you today. And I have this lecture broken up into 2 categories. One is 2D graphics, and I'm going to show you a bunch of examples. I'm not writing anything on the board because you have the printout of all the syntax, but I will try to keep you, I'll try to keep an outline up here so that you can follow everything that I'm introducing. So the first thing that I'm going to show you is 2D plots. 2D plots are basically line plots. Yeah.
We didn't get a sheet.
Are there any extra sheets that somewhere?
Oh, there is.
Did you guys get them all the way up in the back too? Okay. So before we get started, we need to have some data to plot. So I'm just going to be creating all analytic data that we're going to use. So I'm going to do some sine functions. So my domain is going to be from 0 to 2 pi. And I'm just going to pick a small step size between 0 and 2 pi so that my data is kind of smooth and nice looking. And I'm going to start with just plotting this sine of x. So here I'm just creating data so I have something to plot. And I'm going to do this all in the command window. So in order to do just the most basic plot, the function that you use is plot, and it requires it only requires one input. So if you just give it a y, it will actually default to element or locations on the x. But typically it's a good idea to give it an x and a y. And it will, once you activate any plotting command, you will see another figure pop up or another window pop up, which is the figure window. And then everything you do after the plot command goes to this figure until you open another figure. So I have just done a basic plot here of x versus y. Now at the top of my file I have close all, because if I don't have that, when I run my file, the figure doesn't pop up. So you have to go backwards through your windows. Like for me on a Mac, I just go back and like pick the figure. But if you type close all, it closes everything and reopens it, and so it will always come forward. So now, as you're writing your codes, you should start every file with close all, clear all, and it just makes your life a lot easier.
Will the figure pop up if you add a semicolon again?
Behind, yeah, the semicolon or the thing to suppress doesn't do anything for any plotting command. It only suppresses things to the command window. So what we talk about a lot in this topic and what we start to explore is plot customization. And I'm telling you right now that there's almost nothing, I can't tell you it all. So I have to just tell you as much as possible, and then you have to learn to use the help. Because if you want to do anything to your plot, you can in MATLAB. If you want to customize it in any way. So I'm going to show you all of the basic customization. So for example, I typed the word figure here. That's going to pop up a new figure, which I always do so that I'm never overwriting an existing figure. So if I'm creating a new plot, I just always type the word figure. And then I just plotted in a regular line plot with plot XY. And then you can do all this stuff to label your axes. So X label, Y label will label the X and Y axis. And then title is the function name to put a title above the plot. These commands all require, as you can see, a string, and that string gets placed in the location that the function tells it. All of that can be customized. You can change the font size, the font, the bold, the italicized, the color, and all of that you can see in the help of these commands. Yeah.
So if you didn't type close all, but you have figure, just keep opening more and more windows of the plot, right?
No, it's actually the opposite. So if you didn't type close, oh, no, that's true too. So if I didn't have close all and I kept running this and I have the word figure, it will create a new figure. So if I ran this 10 times, I'd have 10 figures. That's true. Yeah. That's another reason to close all. So that's how to customize kind of the look and labeling of your plot. A big one that I always do is that I always like to increase the line thickness because the default line thickness is very thin. In fact, it's kind of hard to see on the projector. So you can see here that I typed plot again, and everything that I had previously written, the labels, are now gone. Do you see that? That's because once you type plot, it holds the plot and does all the customization, but when you type plot again, it's going to overwrite everything. So it's not a big deal, but the order of those commands does matter. Is there a question?
So does it always automatically add a trend line then to your plot?
That's a good question. That's actually what I'm going to show you next. So that is important to remember that these are points that I'm plotting. And by default, MATLAB doesn't use markers, and it uses a connecting line. That's the default style, but that's what I'm going to show you how to customize right now. So there's two different ways to change the, change the line style and color of your plot. And so I'm going to show you both ways. Option 1 is the shorthand way to change and customize the line. And it's really quick and really easy to do. However, it is very limiting because you can't do all the customization with the shorthand. So the shorthand basically has 3 different strings in order. I've only included 2 here. R means it's going to change the line color to red, and the colon means that it's going to change it to a dotted line. The third one is a marker. So if I put a star there, it's going to, I have a lot of points here because I have like over 200 points, so you can't see it. So let me change that so we can see what's going on here. So I'm going to make it so there's only a few points. So here I've said I want a star marker on each point. I want the whole thing to be red, and then I want there to be a dotted line in between. So those are the 3 shorthand that you can use, but it doesn't allow you to change the marker color and the line color differently. There's only some shorthands for some styles. And then if you want any color other than a color that has a letter associated with it, you can't use it. So that's the first option. They do need to be in that order. So it's marker, color, line style, I think. Maybe not. Do you want to try it? No, they don't need to be in that order. Oh, actually, no, it didn't actually run that because there is an error. They do not need to be in that order. I think they all have unique identifiers, the color, the line style, and the marker, so I don't think the order matters. Question?
Well, first, if you type red, would it work? And also, could you use any figure or symbol instead of star, like a capital L?
No, you can't. There are certain symbols associated with this shorthand. So if I go to the help and I look at the plotting help, and then if you go all the way down to the bottom of the function name, this actually works with any function. There should be something called properties listed at the bottom, and that's where anything that you can customize is going to show up. So here, these are the marker symbols that are available. For colors, I'm going to show you the color thing in a second. The color thing is actually consistent across all. You actually can use the string red, but that's kind of a different thing. I'm going to show you the other way to do it right now. That's a little bit more general. So if I wanted to do it the longhand way, which allows me a lot more options, you basically list your X and your Y, and then you list a property. And so you're going to have to go into the help and look up what the property is called, and it's always a string. And then you use then after the property, you put the property value. So here I'm saying that I want it to be red, and I'm using the Roy G. Biv, like Roy G. B. color array. So it goes from 0 to 1, and you just say how much of each color you want. So 1 would be red, a 1 here, and a 0 here would be blue, and you know, you can look these up actually. If you just Google it, you can look at the color codes for different colors. But you can also type red here. There's a couple other options, but this is the most general option. And then for line width, line style, the property is called line style, and then again you have to go look up what the codes are for the different line styles. Line styles, there's only so many. Markers, there's only so many, but you can actually write your own M files to make elephants a marker style, but you have to write it yourself.
Is the color, what is the order of those colors again?
Red,
Blue and yellow, or yellow?
blue, green. Yeah, that's what it is. You can also do it the other way. What's the other style? The yeah, with cyan and stuff or whatever. There are other ways to do it. CMYK, yeah. But it's only if you are like sensitive and you want like a slightly darker red or something. Do you know what I mean? But it's just available. Question up in the back? No, they don't. All strings like this are not case sensitive, but MATLAB is case sensitive with variables. Okay. So another thing I wanted to show you is a scatter plot. I ask you to use scatter plots a lot in the codes that we write. And I wanted to show this because there is a function called scatter, and it works just like plot, so you can do scatter XY, but none of the plot customization is the same. So I think it's better to just get used to the standard plot so that you can do any customization quicker. So if you want to do a scatter plot, what I would recommend that you do is just use the shorthand and leave off the line style. If you leave off the line style, it will only give you the points. So you can do it with option 1 that way. And then if you want to do the same thing with sort of the longhand, then you would need to turn off the line style by just giving it a property value none. And then you would still need to indicate the rest of it. So I'll just show you some of it. Blue is actually the default color. That's the first color that MATLAB always uses. So I'll leave that as is. And then you can type marker and then the marker style, and it should do the same thing. This keeps overwriting my plot, just so you know. Okay. The next thing I wanted to show you is how to create multiple lines on a single plot. And again, there's 2 ways to do it. And it just depends on how much customization you need to do in order to decide which one is best. So the shortest way to do it is to just list both of the things that you want to plot in the same plot command. And you're allowed to use the shorthand customization behind if you want to customize in that line. So here it's going to plot XY as red and then X2Y as K. And it just plots them both together on the same plot. That's great, but again, it's a little limiting if you want to do specific things to each plot. So the alternative is to use the hold on feature. And this is typically what I do. So you can do the first plot. Here you're allowed to use long or shorthand customization. And then you type the word hold on, hold space on. And then you plot the second command in a separate plot function. And you either, you don't have to type hold off. If you're going to create another plot, it automatically turns it off. Or if you open another figure. But if you are, I don't know, doing something, you can turn hold off. So a lot of times a linear plot for an XY line plot is not what you're interested in visualizing. So an alternative option is the log options in MATLAB, which are really useful. We're going to use them in several labs. So just like some of the data that you've been dealing with in lab already, The idea behind a log plot is when you have data that spans several orders of magnitude, a regular XY plot is really not very useful way to look at the data. So I'm going to give you an example here. I have some data that spans several orders of magnitude, and I'm going to plot it using a regular plot. So let's just look at what it looks like. So basically, everything that has small variations, you can't tell how different they are because these huge numbers are shooting the axis up so high. So what you can do, so this would be a regular plot, so I'll put in a title here. You can do what's called a log-log plot. That's going to put both axes on a log scale. And let me show you what it looks like first. And it logged both axes, and so we don't really need to log the x-axis because it's just 1 through 10, but that's just the function name for it, log-log. But you can see that it's much easier to see the values of the data on a log scale. Another option, the other two options are the functions semilog x and semilog y. So these will log only one axis. So semilog x logs the x-axis and semilog y will log the y. So I'll label those. So now I have 4 different plots, and let's say I wanted to look at them all together. That's where subplots come in. So the way that subplots work is there's a function called subplot, and there's 3 inputs to the subplot function. The first 2 inputs split your figure into a grid. So if I put 2, 2, it's going to split my figure into 2 rows, 2 columns, giving me 4 different figures to plot into. And then the last number that you put in the subplot command will just indicate where you want everything underneath it to go. So if I just have my subplot split into 2 by 2, and then I put the first one in the first spot, the second one into the second plot, the third one into the third, and the fourth into the fourth, you'll see that what it gives me is all the plots in one figure. And that's really convenient, especially if you're looking at comparing similar data on the same plot. Yeah.
So the 2 and 2 represent that is going to be a 2 by 2 table, and then what does the 1 represent?
It represents what the commands underneath it will plot to. So this says plot to the first one, and then everything underneath it goes to that first spot, so this spot here, until you put in the subplot command again. And now I have 2 here, so everything underneath that is going to go into the second spot.
Oh, so basically it's making sure that all of the plots are on different
in different spots. So this is 1, this is 2, this is 3, and this is 4. Okay, the next thing I want to show you is the set command. The set command is a really useful command that allows you to do just about any customization that you want to do. So let's say that I'm just looking at a plot of x1 and x and y1. And I'll just open up a new figure to look at that. So there's my plot. And let's say I wanted a different thing labeled on the x-axis, like a different tick marks. This can all be done through the set command. So I'm going to show you a lot of different things, but I'm just going to show you one here, and I'm going to send you a document that shows you all the different things you can do. But the set command works by calling off an axis to change. So GCA stands for current axis. So if you just want to change the last one that you plotted, you can always type GCA, which is what we always do. Then you need to give a property to change. So I'm going to change the xtick label. And then you need to add a property value to change. So for example, let's say that instead of numbers, I wanted to change the xticks to some labels, and you're going to do this in your lab. You need to change the label of one of your axes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just try it. If you don't have the exact amount, it just actually repeats them. But here it relabeled those 1 through 10s with those letters. And if you want to change anything, if you want to change the tick marks, if you want to change the font size of the entire figure, the color of the figure window, do you see how it's gray? You could change it to white. All of those things can be changed with the set command, and you have to look up the property values the same way that I just showed you to look them up with the plot command. Okay, I also wanted to show a text annotation because those are really useful and we use them all the time. So to add a text annotation, that means like a little message on the plot somewhere. So let's say that I wanted to add like a message calling out one of the numbers on the plot. Let's say I wanted to point out that second point. The text annotation command works by calling out the coordinate you would like it to be located on. So for example, let's say I just wanted it to be on the second point. So I'm going to access the second point of the X and the Y array that I'm plotting with. And then you can just add a message or something. A lot of times I'll add like an arrow. I always forget which way to draw the arrow. And all it's going to do is oh, good. That's the problem. Why didn't I have an arrow? Do I have a Y2 somewhere? Yeah, so the arrow should be the other way. But it's your X location and your Y location, so I just called directly out to the location of the plot. And then you can put in any message. I should change the arrow to the other side so that it's actually pointing to the point. But text annotations are really nice, and I actually show you how to do, or in the lab you do a text annotation with an array of strings, which is kind of fun. Let me just show you really quickly with this other file I have open, some of the 2D stuff. I have so much stuff open, so I'm going to close all. Don't worry, I will let you out exactly on time. I will not go over. I never do. I know you're all just nervous. Okay, so here I have, and I'm going to give you all of this information here, but here I have some plotting commands that you can run to do some 2D plots, and you're going to do some of this in the pre-lab. But basically, if you have some 3D data that you would like to plot, and a 3D data would be like a surface plot basically, there's several different options. There is a contour plot which looks like this, and a surface plot that looks like this. And you're going to do both of those in your pre-lab. The contour plot is just the word contour, and there's a contour and a contour F option. A contour plot is going to look just like this, but the colors aren't going to be filled in, and then contour F fills in the colors. And the inputs for that function are just the X, Y, and then the Z. So if you have a Z function that depends on X, Y, which is what you're going to do in your pre-lab, you're just going to put them in order like that. The surface function, the function is just called surf, and it's the same thing. You just put in your X, Y, and your Z. And actually all the customization is very similar for the 2D plots. And there's a lot of other things you can do. Like this has shading and terp on, which means that there's no black lines showing up like there are here. A color bar can be added by just typing the word color bar. And then there's all these things you can do with the axis. So what I'm going to do is I have created this plotting document, and this is actually something you can do in MATLAB. It's called the publish feature. So all the code that you just saw, I published the code to this document. So it shows you the lines of code and the figures that are created from those lines of code, and I'm going to post this on D2L under content right after class, and you can look at a lot of these details. So please, when you're working on your pre-lab and your lab, look at this before you cry or like worry about all the details, okay? It's all here. Okay, thank you.